Hi everybody. So today what we're going to be doing is we're going to be simplifying rational expressions. A rational expression basically is a fraction where we've got some expressions in it with variables. But let's just talk about fractions for a second. Fractions have, a numerator. That's the top of the fraction. Okay, so there's our numerator, and then in the top, it also has a denominator. There's our word denominator, which is the bottom. All of the rules that we would use for fractions are going to apply to rational expressions because they are fractions. So we're going to be simplifying. We're going to be factoring. We're going to be using some rules you learned last year about exponents. We are going to also not, and I'm going to talk more about this, never divide by zero. Thou shalt not divide by zero. So we're going to talk about that a little bit more in a second. We're going to always leave things in simplest form, and we're going to have a lot of fun with rational expressions. So, anyways, let's get started today. So what is a rational expression? A rational expression, I'm going to give you kind of a couple of different Coach Fred versions of what it means. It's a fraction, okay, made up of polynomials. And we've talked about that word polynomials at this point, okay? It's also considered the quotient. Remember, quotient means division, and a fraction is dividing two values. The quotient of two polynomials. Okay, so an example of a rational expression would be something like this. 2x all over 5x plus 1. We've got a polynomial. This happens to be a monomial. Here we have a binomial because it has two terms. This is considered a rational expression. It's an expression and not an equation. Why? I hope in your head you're saying because it doesn't have an equal sign. So right now we're only going to be working on expressions. So we're not going to be solving anything. We're going to be simplifying them, okay? All right, but there's something that's important about rational expressions. Because they are fractions, they have something called a restricted value. In math, and when we move on a little bit later, we're going to be calling that restricted value a domain. The domain is really what x value I'm allowed to put into the expression that won't make it undefined. So let's talk about undefined for a second. It comes up all the time when I say to you, okay, are you allowed to have in a fraction a 0 in the denominator? Okay? We've talked about this a good bit now. 0 can never be in the denominator of a fraction. If it is, you get a value that is no solution, okay? Another word in math for no solution is undefined. There's no way for us to define it, okay? It's undefined. So we're going to be using these two. All right, so when we're looking for a restricted value, we're looking for the value that would make the denominator zero. We're looking for the value that would make the denominator 0. We can't have a denominator being 0, and that's why I said earlier, thou shalt not divide by 0. Okay? So anytime we're doing that, we have to make sure that we don't get a 0 in the denominator. Now, the thing with rational expressions, guys, is they show up in many places in algebra. So it's so important for us to be comfortable simplifying them and working with them, okay? And I know we don't love fractions, but these aren't so bad. Actually, I find them to be easier than regular fractions. All right, so let's look at an example of how you simplify a rational expression. That 2 somehow got here. So I've got a cubed b squared minus 2a to the 5th b. The first thing that you have to do, based on the original expression, you have to find your restricted value, okay? If there is one. But it's based on the original expression. So I look at it and I say, okay, what value could I put in for a that would make the denominator 0? Well, the only value that I can make a would make the denominator 0 would be 0, because 0 to the 5th power is 0. So a cannot be 0. And that's how I write it. A cannot be 0. The same thing with b. If I make b 0, then the whole expression would be 0. So then b cannot be 0. So you state your restricted value if you can first. Sometimes it's easier to simplify it, and I'll show you in a minute what I mean, okay? All right, so then you simplify. Now, this is all being multiplied, a cubed times b squared, 2 times a to the 5th times b to the times b. And you learned last year when you did exponents that you're allowed to subtract the exponents. I always say bring the smaller value to the larger and subtract. So a cubed, the cube 3 is smaller than 5, so I'm going to bring it down to the to the denominator. That negative 2 is going to stay where it is. And I'm going to do a to the 5 minus 3, which is 2. Okay? I've taken care of it. I'm just going to kind of cross it off. B is b to the 1 power, so I bring the 1 up and I subtract, and I'm left with b in the numerator. Okay? So I've simplified the rational expression. There's nothing more that I can do. Okay? That's one working with just exponents. And if you have problems with exponents, please see me. You did it last year in Integrated A, and I want to make sure that you still feel comfortable with it, okay? So if we need to get you some help on that, no worries. It's been a while. All right, let's look at the next one. Actually, you know what? I'm going to add a page because I want it to be in the middle. So 5x minus 10 all over 5x. Okay, so we have to do our restricted value first, our RB. Okay, our restricted value, also called domain. It's the value of x that would make the denominator 0. All right, well, looking at this, the only number that I could put in here for x that would make this bottom 0 would be 0. Like if I put in 1, I'm going to get 5. If I put in 1/5, I'm going to get 1. Put in a negative, I'm going to get a negative. So the only number that x cannot be is 0. And again, you have to do it before you simplify the expression. All right, so how do we simplify this expression? We are not allowed to cancel these 5x's. Why? Because this is an expression that has subtraction. You can't just cancel through addition and subtraction. You can only do that with multiplication. So you have to use our factoring rules. And step 1 when we factor is always to take out what? I'm hoping you said it, the GCF. So in the numerator, I'm going to factor out the GCF, which is 5. And I'm left with x minus 2 all over 5x. Now, we've made this multiplication, and this is multiplication. So now I am allowed to cancel these two 5's, not the x's, but the 5's. So they will cancel to the number 1, and my simplified expression would be x minus 2 all over x. Nothing more I can do. Not allowed to cancel these x's because this numerator has an expression with addition and subtraction in it. Okay? Make sense? All right, let's do another one. Oh, you know what? I am going to just switch to writing my own. They're not showing up so good today. Sorry about that. X minus 4 all over 4 minus x. Okay, so this is a little bit harder. I want us to look at that. Can anyone tell me in your mind what those look like? Do they look similar in any way? I'm hoping you're seeing that this is x minus 4 and this is 4 minus x. They're kind of backwards. If I were to rewrite this, could I do this? Could I flip this around and say this is negative x plus 4? Could I do that? All right, I do that just so that you can see what these actually are opposites to each other. Look, the negative x and a positive x. Negative 4 and a positive 4. If you ever have situations where there is a opposite, you're allowed to factor out a negative 1 to make them look similar. So for example, if I leave the numerator, if I factor out...
Sam Essig, please come to the middle school office.
Sorry about
Sam Essig.
Okay. If I factor out a negative 1 in the numerator, in the denominator, I'm going to be left with negative 4 plus x. Look at that. If I flip these around, isn't that x minus 4? So if you factor out a negative 1, you've made these look the same, and now you are allowed to cancel these full expressions now. They are the exact same expression over the exact same expression. So it would cancel to 1, and 1 over negative 1 is negative 1. Oops, we forgot to do our restricted value first. Our restricted value. What value in the original expression would make the denominator 0? 4 minus what would give me 0? Hope you're saying and seeing that it has to be 4. So x cannot be 4 in this expression, or we're going to get denominator of 0, which is undefined value, and thou shalt not divide by 0. Okay? All right, let's do another one. A little bit harder. Where do I want to go from here? I want to go back. All right, so we're going to do x squared plus plus 6x plus 9 all over 3x plus 9. Okay, so we have to do our restricted value. Now, this one's a little bit more complicated because we have to figure out what value is going to make this whole expression 0. When they're more complicated, sometimes what I like to do is actually set the expression equal to 0 and solve, because that will give me the value that will make the equation 0. Okay, that will make that expression 0. So if you set the expression, the denominator, equal to 0, it will give you the value that is going to make the expression 0. That's what that does. So I would subtract 9 on both sides, and I'm left with 3x equals negative 9, and then I'm going to divide by 3. So I get x equals negative 3. So if I plug in negative 3, I get negative 3 times 3, which is negative 9, plus 9, which is 0. So that means that this is my restricted value. So x cannot be negative 3. Now, some of you on these easier ones are going to see that it's negative 3. Do you have to do this work? No. But this is why and how of it. So if you need to, if you don't recognize the restricted value, you know what to do. So you set your denominator equal to 0, you solve the expression, or the equation that we've created, and that would be your restricted value, okay? So we know that now x cannot be negative 3. All right, now we have to go back to, this is a trinomial. Trinomials, I want to remind you, is that you may need to factor trinomials. So let's review factoring a little bit. I'm trying to find the factors of 9 that add to 6. So I write down all my factors of 9, which are 3 and 3, and 9 and 1. And then I make my two binomials. I put x and x because the number in front of the x squared is a 1. And the factors of 9 that add to 6 look like they're 3 and 3. Okay? So I'm going to have plus and plus because these are both plus. Hopefully you were remembering factoring since I just reviewed it with you the other day. All right. Now if you want to, don't forget you have your smiley face check. You check to always make sure in your head that x times x is x squared and 3 times 3 is 9. But do the inners and the outers, the nose and the mouth of the smiley face, do they indeed add to 6x? They do. So you've checked it and your numerator is simplified. All right, now we look at the bottom. I look at it and I say, can I factor anything out? I'm just checking the time. I can. I can factor out a 3. If I factor out a 3, I'm left with x plus 3. Okay, so now I have equal expressions over equal expressions. You are allowed to cancel as long as the expressions are exactly the same. You're allowed to cancel some of them, okay? Now in the numerator I have 2x plus 3's, but in the denominator I only have 1, okay? All right, so I can only cancel one of them. So I'm going to cancel this with this. Those reduce to the number 1, and so I'd be left with x plus 3 all over 3, okay? And that would be my simplified expression. And I want you to kind of look now. Now, I don't have a variable in the denominator, so can it ever be 0? You can never make this denominator 0, but you could originally. So you always have to look at what you did originally. Okay, we're going to try one more, and then I'm going to stop for today. Okay, so we're going to actually go to number 7. Okay, so everybody's looking at number 7. 7x minus 14 all over 2 minus x. Okay, the fact that I've got 2 minus x tells me something in my head. Maybe I'm going to be dealing with opposites because it's not in the form x minus 2. All right, so I look at it and I find my restricted value. My restricted value is that x cannot be, hopefully you're seeing, cannot be 2. Because if I put in a 2 for x, I get 2 minus 2, which is 0. All right, Then I look at the numerator and I want to simplify. And I see that there's a GCF of 7. And pull out the 7 and I'm left with x minus 2 all over 2 minus x. Which Fred's hoping that everyone sees that these are opposites, okay, opposites. So I'm going to take out a negative 1 from the denominator. So I'm going to leave the numerator. I'm going to take out a negative 1, and then I'd be left with negative 2 plus x, which is the same. And if I wanted to rewrite this, I could. These two now are exactly the same, expression for expression. You can cancel them to the number 1. Okay? And so now I'm just left with 7 all over negative 1, which is negative 7. Okay? All right, and that's my answer. All right, so tomorrow in class, we are going to finish this worksheet up, and we're going to start practicing. And this is going to take some time to understand the restricted value, and they are going to get slightly harder. I'm going to do the harder ones in class, okay? All right, so hope you have a great night. Bye-bye.